All right, notes for section 2.7, division of real numbers. We have two goals. First, I can divide real numbers. And number two, I can use division to simplify algebraic expressions. Our notes are pretty short because it just says the product of a number and its reciprocal is 1. Now, a reciprocal just means that if you have a fraction, all we're going to do is we're going to flip it around. Whatever's on the top goes on the bottom. Whatever's on the bottom goes up top. So the reciprocal of 3/5 would be 5/3. If I have 1/2, the reciprocal of 1/2 is going to be 2/1. Or we don't have to write it as 2/1. It can just be 2. A lot of people get that confused. If I have 7 and I want to find the reciprocal of 7, then that's going to be 1/7 because this is the same thing as saying 7/1. If I have -3, the reciprocal of -3 is still going to be a negative because negative times a negative is a positive, and this will be -1/3. So if I take any of these numbers and I multiply them, I will always get 1. So if I take this times this, it's 1. This times this is 1. This times this is 1, and so on. So what we want to do is we want to find the quotient. So to find the quotient, what we're going to do is, I'm sure you guys can do most of this in your head, but if we wanted to, we could also change this to a multiplication problem. So -30 divided by 10, obviously you probably know is -3, but if we want to look at it a different way, we can always look at it in terms of multiplication. We can change it to a multiplication problem, and we can write 10 as 1/10. Now -30 can be as -30/1, so -30 times 1 is -30, and 1 times 10 is 10, and we get -3. Now that's a lot of work for problems that we can do pretty much in our head. For example, negative divided by negative is a positive. So I know my answer is going to be positive. 24 divided by 6 is 4. So with these, it's pretty easy to do in our head. In this case right here, I have 5 divided by -1/3. So what we're going to do is we're going to change this to a multiplication problem, and we're going to do the reciprocal of -1/3. The reciprocal means that we're going to still be a negative sign, and we're going to flip this around, so it's going to be 3/1, or just 3. Now if I do this, I know 5 times -3 is -15. Now some of you guys might have learned in some of your other math classes that you can copy, dot, flip. That's the same thing as just saying multiplying by the reciprocal. On part D, if I do this, I have 36 divided by -3. 3 goes into 3 one time. 3 goes into 6 two times. Positive divided by a negative is a negative. All right, we also have these types of problems where it says use the distributive property to simplify. I'm going to show you a couple different ways.
Brianna Hefner, could you please come to the front office? Brianna Hefner.
I'm going to show you a couple different ways to do this problem. First off, if we wanted to, we could rewrite it so it's 48x plus 6, all inside parentheses, and then divided by 6. Now, to do this, we would have 48x plus 6, and remember, copy dot flip or multiply by the reciprocal, so times 1/6. And if we have a problem like this now, we would want to take the 1/6 and multiply it by everything in 48x plus 6. So 1/6 times 6, well, those are reciprocals. That's going to give me 1. So I'm going to have 1. 48/6 is going to be 8. So I'm going to have 8x plus 1. That is how you'd solve this problem if you use the distributive property. Now, not every time would I use the distributive property for this. What I like to do whenever I have a problem like this is I like to break it up into two fractions. I like to say, hey, I'm dividing 48x plus 6 divided by 6, so I'm going to take 48x. and I'm going to take 6. And I'm going to divide each of the parts by 6. So 48 divided by 6 gives me 8x. 6 divided by 6 is 1. We get 8x plus 1. Let's try the next one. So on the next one, I'm going to do that same method. What I like to do is I like to break it up into two parts. Negative 35 plus 14y. This is all being divided by 7, so I'm going to divide this by 7 as well. So negative 35 divided by 7 is negative 5. 14y divided by 7 is 2. Don't forget your variable, 2y. There's your answer. All right, on the back side, we have you practice, and then we also have a few more examples, one of which is evaluate the expression for the given variables. So we have 2m minus 9, 2m minus 9 over 3 when m equals 6. That means wherever we see an m, we're going to plug in 6. So it's going to be 2 times 6 minus 9 over 3. If we do this, I know that 2 times 6 is 12. 12 minus 9 is 3. And I get 1. Now you'll notice this is probably the only time that you'll see me working horizontally. Whenever I have a fraction, I like to work horizontally because I have a numerator and I have a denominator. And I like to keep things up in the same level. I like to keep my numerators in the same level, and I like to keep my denominators in the same level. So if I do this, I like to work vertically. Now I noticed I didn't do an equal sign, I used arrows. I don't do equal signs because then a lot of people think, oh, I have to solve it. Well, that's not the case. This is your simplified answer. All right, let's try part B. On part B, I'm going to plug in 8 for x, or 8 for y, and 2 for x. So I'm going to simplify. So this will be 8 minus 4 divided by 2, and then 4 over 2, and this gives me 2. All right. On finding the domain of the function, what we want to do is we want to find the domain of the function. Now, the domain is the x value. If I have a graph, one thing that I want to do with my graph is what I can do, I pulled up a graph. This is called Desmos. It's a pretty awesome tool. So if you use Desmos, what we want to do is I can actually plug it into the equation that I'm doing into this graph. So if I do this, this will be y equals 1 divided by 2x. Now you'll notice that the graph looks kind of crazy. So it's going up and it's going down. This right here is called an asymptote. An asymptote means that this value does not exist. So my domain in this case is going to be all the values except for when x equals 0. Now why is this the case? Well, the reason why this is the case is because if I look at this graph and I have y equals 1 over 2x, I know that the denominator, which is my bottom number, cannot be equal to 0. We cannot divide by 0. So if I'm doing this, I know that if I set the denominator equal to 0, that cannot happen. So I want to figure out that one number where the denominator cannot be. So if I divide by 2, I get x equals 0. So my domain is going to be all real numbers, except for 0. Because it'll work for all numbers, it just won't work for that 0. So in part B, we want to find out what number we cannot have in the bottom. So I know that I can't have 1 divided by 0. That won't work. So if x plus 1 is equal to 0, what's the value of x that I can't plug in? Well, if I solve this, I get x equals negative 1. So I know that it's going to be all real numbers except for when x is negative 1. So this will be all real numbers except for negative 1. We can check that with a graph if we wanted to. So if we wanted to pull up our graph, we can do that. And we can see what we get for that. All right, you can do that using Desmos if you like. For this one, I know that the bottom can't be 0. I cannot have 1 divided by 0. So notice x minus 1 and 0 in the same spots. So x minus 1 equals 0. Solving this, I get x equals 1. So I know this will be all real numbers. Except for 1.